There we go. That's better.
Rosie,
What's up?
Skylar might have COVID.
Huh? Who did? Is
Skylar.
that why he wasn't at baseball yesterday?
Yeah, he got tested today.
Okay.
The
Let me know.
reason Danica is
Gosh.
singing right now.
I was actually going to text him to see if he wanted to meet with me tomorrow to do some baseball stuff. But yeah, let me know. Hopefully
Okay,
he's
yeah, I will.
Cool. All right. Well, welcome everybody. Thank you guys for being here. I would love to just get right down to it. On these remote days, I want to start on time so we can get out early if possible. I don't want to start late and keep you all the way. I'd rather start early or start on time, and if we can, get out early. Today, I just kind of want to do a couple recap, quick things. Whatever I can do to kind of bridge the gap from last semester, which feels like forever ago, to this one, because the chapter that we're in, we stopped in the middle because that's how far we got. And I want to make sure that all of that stuff from last semester that has to do with this chapter doesn't get lost, and that you just kind of all start in the same place. So let's write some stuff down. I just want to kind of recap some stuff, take us on the right way, something to write on. I'm going to try to keep it short and sweet and simple when it comes to the stuff we already know. We'll see how much time we have. I'll just kind of get things going today. Tomorrow will probably be our bigger day when it comes to doing new stuff for the first time. I just kind of want to take today to recap some stuff. So have something out that you can write on. I would start someplace nice and fresh, whether it's a brand new notebook or at least just a brand new page somewhere. Nothing you'll have to submit to me on Canvas today. We'll start with that tomorrow. I want to give you credit for the work that you're doing on these days, which means like giving you some classwork credit just for being here and taking good notes and doing the problems, even if the ones that we do together. It's going to be such an important part of what's going to help you do well later, like tomorrow, next week, the week after that, as we work through some of this harder stuff. Now, I don't think there's going to be a lot of brand new stuff that you haven't seen ever. It's just going to be new to you and me. We haven't talked about some of the stuff that we'll get to tomorrow. So chapter 2 is where we're at still. And I'm kind of following along with the textbook in terms of what they do and when they do it. Just to kind of give you some consistency that if we do end up jumping back in the textbook or what have you, we've got a place that we can go back and kind of rely on the same curriculum. So chapter 2 was all about quadratics. It's quadratic functions. Right. And we did a lot. Honestly, we did. We got pretty deep into this, like from I guess probably even before Thanksgiving. We started this, and then when we went remote after Thanksgiving, we did a couple things, and then we started to review. Right. So that's it's been a while, and so I want to touch on a couple things that we saw when it comes to dealing with things. Right, quadratics. Anything whose biggest power is just x squared, okay? Now it could have power smaller now, or it could have just an x in it or just a number, that's cool too, but it's gotta have an x squared and nothing bigger. And so we looked at a couple different versions of what that stuff looks like that give us different kind of details about what those graphs are going to look like, where they're gonna fit, left, right, up, down, where the vertex is, where they're going to run to the y-axis, all that stuff. And I just wanted to have today to be a day where I could touch on some of the stuff that we saw in different sections, okay? So we're going to look at the different forms of these quadratics and the way that they could write them down. And the first one that I think that we started with was vertex form. That was the first one, okay? Now I could call it y equals, I call it f of x, g of x, h of x, whatever I want. I'm gonna stick with that function notation so we start seeing that again. It doesn't matter, remember, it doesn't matter what letter I choose at the beginning, whether I call it function f or g or a or b, q, any letter I want. The most common one, obviously, because it's a function, is gonna be f. Okay, so f of x equals. Okay, and when I go from vertex form and then to the next one and then to the next one, I'm going to change this letter just so that you can tell them apart from one part of your notes to the other. But remember, it is completely arbitrary. I'm just picking one so that they're different. Okay. All right, vertex form looks like this. It's got to have an x and it's got to have a squared in it, but there's some other stuff that we can do to shape this parabola however we want, right? We can stretch it out, shrink it down, slide it left, right, up, down, whatever we want to do. And I'm just going to kind of give you that general form of what that looks like, okay? It always starts right after the equal sign with that A, right? Right, and that's what's really nice is that that's true for every single form that we look like. The first thing right after the equal sign will always be that A. And that A right there does the same thing no matter what it looks like. That's going to be that vertical stretch or compression. That's what's going to tell us if it's going to like be really like super skinny because it's stretched out, or super flat because it's compressed down to the x-axis. The other thing that it does is it could flip it upside down. Okay, if A is positive, so if A is greater than 0, that just means positive, right? Bigger than 0, then we're going to open up. So I'm just going to draw like an upward facing parabola with the arrows going up. And if A is less than 0, then we're going down. Okay, and I'm not going to worry too much about what makes a stretch and what makes a compression. This is kind of the most important part. I want to know if this thing's pointing up or pointing down. And it's really just the sign of that number. Cool. All right, now vertex form is a little bit different. And the reason they call it vertex form is because the only other thing that we can tell just by looking is where that vertex is. Wherever that turning point is, whether it's the maximum because it's upside down or the minimum because it's right side up. And that's going to happen in 2 spots, right? Because the vertex is the point. Some x coordinate, some y coordinate where that thing takes a turn. But I still need my x. I still need that x squared in there somewhere. It happens on the inside of that set of parentheses, okay? And leave a little space here for a second. Close those parentheses. There's the squared, right? There's your x squared. And I know the x is kind of buried on the inside. The squared's on the outside. It's all good. You still have that x squared. But next to this spot right here is where we're going to see part of that vertex, okay? And the way that we're going to write it is we're going to have that x minus h over there. Hopefully you guys can see that. Let me know if things are too small or too faded or something like that. Okay, x minus h, and the reason it's minus is because it's inside, right? And that's a horizontal shift, and horizontal transformations are always backwards, right? They're going to go in the opposite direction than we might expect. Okay, and that's part of my vertex, right? Here's my vertex right here. And it's that number right there, that's the x part, right? And we call it h because it's horizontal. It's that horizontal shift going the other way. But remember, x minus h, so you want to switch the sign, right? Horizontal transformations are the opposite from what we might expect. So if this was like x minus 2, then this is just 2, just the positive version of that. If this was x plus 7, whatever, making it up, x plus 7, then this would be -7, right? Switch that sign. Cool, but every point has both an x value and a y, so I need another number right here. I need that vertical shift. And we just called that k, okay? Now that's gonna go in the direction we expect. That's why we're gonna use the plus, because if it was +5, cool, let's go up 5. It's -3, cool, let's go down 3, and we'll get ourselves to that spot. And that's all we can really tell just by looking at some function that's written like that one, okay? And I just want to look at one quick example to make sure that we've got it. So I'm going to slide over here. So that's kind of the note section. If I were you, I'd probably put this like below these notes down here, but I'm out of space. So I'm just going to slide over here so you can kind of see them next to each other. I'll separate it like this. But if I were you, I mean, put it wherever you want. They're your notes. You can design them however you want. But I'm just going to make up a function. And you tell me what you know about it. All right, so I'm going to put like 2, so I'm gonna call it f of x again, so that they're similar, so that I can call it whatever I want. F of x equals 2, parentheses, x plus 4, still inside the parentheses, but now I'm gonna close them. To make it quadratic, I need that exponent of 2 up there. That's the one thing that makes that kind of shape. And then let's go like plus 5. Okay, if they give us a function that looks like this, and they say, hey, tell me everything you know about it, just by looking, not having to do a whole lot of work, but just tell me something that you know. I'm just going to put like a little bullet point right here so we can write some details down. Tell me anything. If you got an idea, unmute yourself and give me a shout. You got f of x equals 2 times x plus 4 squared plus 5. Give me anything you know.
Well, it curves up.
Nice. It opens up. How'd you know that?
Equals the 2 there at the start is greater than 0.
Perfect. It's positive. If your leading number right there, that number out in front is positive, we're opening up. Good. Okay. Tell me something else. Somebody else. Somebody different.
The x of the vertex is -4.
Nice, good. I know where the vertex is. I know what that turning point is going to be. And the x value is just the opposite of whatever that number is. Good, nice. Cool.
The y is 5.
Perfect. Positive 5. Keep this number exactly the same. Exactly what it was. Nice. Now, one last detail that might be nice to know is whether or not that vertex is at the top of the parabola, where we call it a maximum, or at the bottom, and we call it a minimum. The vertex is a, which one? Is that
Minimum.
going to be a maximum, or is that going to be a minimum?
Minimum.
It opens up like this, right? Absolutely. It's got a lowest point at that spot. Beautiful. Done. Love it. That was basically section 2.1, right? We looked at vertex form, we figured out, and we kind of messed around with it by looking at different graphs and what we saw based on plugging in different equations and what it told us. Love it. 2.1, done. Moving on. Switching gears, switching sides. Let's see how that looks. I'm turning a little bit. Okay. Yeah, a little bit more. There we go. Awesome. Nice. All right. The next thing that we looked at after that was the one that was just a little bit trickier because there was a little bit more work that went into being able to find things like the vertex, right? And that was called, I'm going to try to stay below the glare up there. I'm trying to write big. We called it standard. And I kind of like that they actually started in vertex form. A lot of textbooks would have started here with standard form. Vertex form is really nice. And you're going to actually see as we get further into this, by the end of chapter 2, you're going to see that I actually prefer vertex form for a lot of things. And it's not just finding the vertex, but finding out a lot of different things about what these parabolas look like. But standard form is great too, and they call it standard form because this is the one that we're probably going to see the most. If I had to pick out a group of these quadratics that every class, like Algebra 2, even Algebra 1, but like beyond Algebra 2, if I was going to write a quadratic down, they're probably going to look like this. Now, if I wanted to, I could write f of x again. I'm going to switch it up just to be different so that we get used to it. I'm going to call it g of x. Hopefully you can see that. All right, I'm pretty close to that glare up there. I know, so I'm going to come down a little bit. But right after the equal sign, every single time, it's always going to be that a. And I'm not going to write it again, but that a is exactly the same as the last one. It's the vertical stretch of compression. If it's positive, we're going up. If it's negative, we're going down. And that's why we use the same letter, okay? But what you'll see is that that's the only thing that's the same between vertex form and standard form, okay? Standard form does a couple things that are really nice, but also it takes a little bit of work to find some other things after. Okay, now what I'm gonna do to keep things in standard form, and this isn't just standard form of quadratics, this is actually standard form of all kinds of functions. No parentheses, which can be really nice because you don't have to worry about like distributing or multiplying, things like that. And we're gonna put things in order from largest to smallest. I'm gonna put that x squared term first. This way you know that we're dealing with a quadratic. And I'm not gonna put some like hidden x cubed or x to the fifth or something weird over here. If it's in standard form, the largest exponent, it's always gonna go first, and then we're gonna go on down from there. And so I don't know what classes you guys are gonna end up taking next year. We're actually gonna have that conversation really soon. I believe, and this is just me thinking, I don't know if this date is exactly correct, but this is the one that pops into my head, but January 20th is registration day for next year. And so freshmen, sophomores, juniors, we've got some things that we want to talk about in terms of what you might want to take next year. And I know that we haven't even barely started second semester yet, but we actually have to start thinking about the fall. And so some of those classes that you might end up taking next year, you start looking at things like x cubed and x to the fourth and x to the fifth and x to the 47th and x to the 1,900,000 whatever. We can get up to that big crazy stuff and start dealing with really cool things. That would be a class like pre-calculus. That would be a class like college algebra, which to me is like Algebra 3. So if like algebra is your jam, maybe those are the directions you're heading in. If you're feeling like this class has kind of rekindled some of your algebra love, that might be a direction you go in. But we'll talk about that in the next couple weeks for sure. Okay, cool. So let's go down from there. We've got this x squared term, awesome. Let's go down from there. So I'm gonna connect this with just a plus sign. Now, of course, it could be a positive number or a negative number. We just use the plus to say, you know what, whatever that sign is, keep it, right? Just like we did back there with the plus k, whatever that number is, keep it, don't change the thing, okay? And now I'm gonna use a different letter than A for my next term. Well, let's just go B. Let's just pick the next letter down because we haven't used that for anything yet, so that's a good one. And because I've already used an x squared and I wanna go down from there, let's just have it be x to the first. And of course, I certainly don't need a 1 up there. If it's just x, we know that that's x to the first. Okay, cool. So x squared, so ax squared, plus bx, so x to the first. And then down from there, well, x to the 0. And if I have 0 x's, I certainly don't need to write an x anymore. That's kind of what x to the 0 means. It means I have 0 x's being multiplied, but there could be a number attached to that. So I'll just put like a plus C, A, B, and C. And we can use those numbers, just like we could use A, H, and K with vertex form, we can use A, B, and C, and sometimes combinations of them to figure something out, right? Again, A, still A. Still gonna do the same stuff, I'm not gonna write it again. But there are a couple things that we can figure out about what this parabola looks like, where it is, whether it's stretched out, where the vertex is, some important spots along the way. Some of it just by looking, some of it by doing a little bit of work. This is probably more familiar than the vertex form was. So I don't know, do you guys remember what standard form can do for us? Is there anything that you remember about like a point or anything along the way that we know for sure? Just by looking. Been a while. It's okay if you don't. Okay, let me give you a hint. The y-intercept doesn't take any work because if you are on the y-axis somewhere, right? So I'm over here, I graph it, whatever it looks like. That spot right there where it runs into the y-axis, I don't care where it is, how far up and down. What I know is that if I'm on the y-axis, I haven't moved left or right from the origin.
Is it C?
Nice, yeah. The y-intercept, so it's the y value. It's just c because x is just 0. So I haven't gone left or right from the origin. I'm just going up or down. X is still 0. And if I drop a 0 right there, that's gone. If I drop a 0 right there, that's gone. And the only thing that's left is C. Nice. Good job. That's awesome. That's the easy one. That's the part that I love about standard form. I don't have to do any work. I can just, boom, y-intercept whatever that number is at the end. Plus 5, cool, 5. Minus 6, awesome, negative 6. The vertex, though, not quite as easy to find, but still doable. And this is a really nice shortcut. There's a longer way to do it, which I'll show you. It's like 2.5 or 2.6 or something like that. We'll get to that next week, probably. I'll show you how to do it so that you've got the background, even if you don't master all of these things that we're doing. I want you to have a good background so you can always go back to it. The vertex is obviously it's a point, right? And I'm going to write this kind of big because I'm going to put some stuff in between here. So it's this point. It's got an x value and a y value, but I'm going to show you, I'm going to tell you, remind you about how to find it just kind of right inside here, okay? What we figured out, and it actually comes from, and I told you this last semester, it comes from the process that I'll teach you in like a week or so, maybe 2. Like we figured it out from there. We proved it by doing some algebra behind the scenes, but I'm going to give you the super quick shortcut right now. Is that, okay, we've used C. We already used that number. It doesn't have anything to do with the vertex. That's the y-intercept. That's way over here, right? The vertex is going to use a combination of A and B. And I didn't figure this out. This is way back in the day. People figured this out. They did the math to go with it. And once we really get to the end of chapter 2, maybe I'll prove it to you. It's crazy. It's cool. It's tough to follow. I'd rather do it in person, but we'll see. The x value at that spot, whatever that spot is where this thing takes a turn, is some combination of A and B. And it's this one right here. Negative B on the top of a fraction. Okay, so we've got this fraction, and on the top of that fraction is going to go the opposite. I know I said negative, but I really just mean opposite. The opposite of whatever that number is attached to x. So if this was like a 4, like a plus, whatever to 5x squared plus 4x, then I put a negative 4 on top. Just switch the sign. If this was a negative 4x, okay, I'll make it positive 4. I'll always switch the sign. On the bottom of this fraction, let me make this parentheses a little bigger. On the bottom of the fraction, has to do with A, but we have to take A and double it. So I'm going to put 2A. So if A is 1, okay, this is 2. If A is 4, okay, now on the bottom goes 8. If A was negative 3, okay, this is negative 6 on the bottom. And we just take that fraction and we drop in those numbers and we see what we get. We'll take B, we'll switch the sign and put that on top. We'll take A and we'll double it, put it on the bottom, and then we'll actually divide. We'll see if that fraction is nice. Like 4 over 2, okay, well 4 divided by 2 is just 2, and that would be the x spot. Or 8 divided by 3, well, 8 divided by 3 isn't all that pretty, so we'll just leave it, 8/3, right? Or, I don't know, 10 divided by 4. Well, 10 doesn't go nicely with 4, but it is 2.5, exactly. So we could just call it 2.5, or we could call it 5/2 or whatever you want, right? Whatever that fraction ends up being, that's the x value of that vertex. To figure out the y value that goes with it, go back to the function. That's the whole point. This g of x, f of x, p of x, r of x, whatever you want to call it, remember, that's always just y equals. It gives you the answer for any x value. It gives you the y value that goes with it. So if I know x, all we have to do is plug it back in. Plug it in. We'll just drop in whatever this number is for x right there, x right there. We'll let the calculator do all the arithmetic for us. This is algebra, not arithmetic. We'll let the calculator do most of that work, and we'll see what we get. And then we're done. There's a vertex, okay? Vertex form, really nice. I just look at the numbers. Switch the first one, keep the second one. Standard form, we just have a little bit of work to do. But really, it's just about knowing one thing. This negative b over 2a shortcut. That's all it really is. It's just a really, really nice shortcut. Cool. Questions about either the y-intercept part or the vertex before we do one quick one together? Sweet. All right, let's do it. So write it wherever you want. I'm actually going to just erase my crude little drawing over here. This black marker is already fading. So write it wherever you want. You can put it below this. You can put it next to it like I am. I'm just going to make one up. I'll call it g of x. I kind of like that one. Okay. All right, so here's a function. It's quadratic, and it's in standard form. So g of x equals, let's just say x squared. It'll be x squared. And then like plus 6x minus 2. Taking it up. So g of x equals x squared plus 6x minus 2. And let's do the easy one first. Where is the y-intercept?
Isn't it 0, -2?
Perfect, right? And you can write it as that point just like that, 0, -2, or you can even just say -2. That's cool too. Because as long as you say, hey, this is the y-intercept, then I know exactly what x is going to be. It's got to be 0. Cool. Nice. All right. Now, when we get into this whole vertex thing, sometimes you might find it really helpful to kind of come off onto the side and say, all right, what is A? What is B? What is C? Like taking a second and just kind of coming off on the side and saying, all right, what are those numbers? The first one in front of x squared, the first one in front of x, and then the one that's kind of by itself. Well, if it's just x squared, what's that number sitting there that we don't bother writing?
Imaginary number.
It's not imaginary, but it is kind of invisible right now. Careful with that.
1.
We're going to get to what imaginary numbers are later this semester.
Oh,
Whole thing. But it is invisible to us because we don't need it. If I don't write a coefficient in front of an x or an x squared or an x to the whatever, what is that number? Remember?
1.
Nice. A is 1. B is just the number attached to x. Okay, plus 6x, easy, that's just a 6. C clearly is just that number at the end. That's going to be -2. And there it is, right? Perfect. Y-intercept -2. The vertex is really the part that I care about the most. And so here's how I like to write down the work that goes with this. And I'm actually going to scoot you guys just a little bit closer. I just want you to focus on the parts that matter. Now, the vertex that we have to start with, there's a reason that x comes before y in these points, is because that's how I want to start. I want to figure out what the x value is first. So I'm actually going to just write x equals. And I'm going to write down this nice little shortcut without any numbers in it just yet. -b over 2a. But I'm going to put an equal sign after that and kind of keep connecting this this train of equality until I get to the best version of this number. Okay? B is 6 right now, right? What they want up top is just the opposite of that. So on top of this fraction, let's just put -6. Okay? And as you get the hang of this, you can start to go a little bit faster. I know I'm taking my time here. Just a quick recap kind of day. On the bottom is going to go 2 times whatever A is. And this is why I kind of like writing it down, A, B, and C, especially when it's just a 1, because then it reminds me that, yeah, I know that there's no number actually sitting there, but it is a 1. And so when I do 2 times 1 on the bottom, I'm going to actually leave a 2 down there, not just a 1. And I saw some of us kind of on the practice that we did last semester, and even leading up to the final, some of us put a 1 down at the bottom and kind of screwed some stuff up. Okay, cool. -6 divided by 2. Well, dividing by 2 is just cutting numbers in half. Okay, -6 divided by 2 is -3. Now that's not the whole vertex, but that is the x part, which is why I always like to start with that x equals. And all I need to do now to figure out the y that goes with it is plug it back in. And I've got this function sitting here waiting for me to use it. And I just wanted to remind you of what that notation kind of looks like. Remember, g of x has a bunch of x's in it, right? There's no numbers in there for x yet. But now I've got one, and now I know what I want to use. I want to take that -3 and I want to drop that in for x everywhere there's an x. I want to drop it in right here next to the 6. I want to drop it in here for the x squared. But to show whoever's reading this that that's what I'm doing, I'm going to put it here too. I'm not going to leave it as g of x. I'm going to write g of -3. That's saying, okay, go to function g, plug in -3, and show me what you get. And remember, anytime we substitute, always use parentheses when you write it down here, but especially in the calculator, because the calculator will mess stuff up if you don't do it. So there's an x, so that's -3, but it was squared, so I'll put the little 2 up there. Plus 6, and as soon as the letter x would come out of my mouth, I know, okay, parentheses, -3, -2. Just kind of separate this visually so you guys can see it. And then, seriously, don't do this by hand. Let the calculator do all of that quick arithmetic for you, okay? All in one shot, just take the whole right side and plug that thing in, okay? If you want to go step by step and say, okay, -3 times itself is +9, awesome. +6 times -3 is -18, cool. -2 is just a -2, great. And just kind of work that way. That's up to you. If you want to go step by step, fine. 9 minus 18, -9, -2, -11. You could do that, but honestly, take this step right here and skip it. Go to your calculator, work fast. You've got a calculator in your pocket now. Let's use it, right? -11. Now, the vertex is the point. This was just kind of the work leading up to it. -3, -11. There's my vertex. Okay. Obviously, way more work goes into finding the vertex than it does into finding the y-intercept. But it's work that can be done if you know what to do. If you've got that super nice quick shortcut, that -b/2a, and you know how to use it, you'll be in good shape. Cool. I know I'm going a little slow, but hopefully it's actually at a pace where you're feeling like, oh yeah, I kind of remember that. Or man, I didn't really remember that at all. I'm glad he's doing it. Because we're stuck in this middle of this quadratics unit, I wanted to make sure that I covered this stuff so that it's familiar. So when I go back to it in a week or 2 weeks or 3 weeks, you know what I'm talking about. Cool? All right, sweet. One last thing, because we're down to our last few minutes, which is perfect. So I want to try to get you out of here a little early. I'll go back to this side of things. I'm going to erase all of this stuff from vertex form. And the last one we spent like barely any time on, and that's okay. So that's why this is going to be super quick right here. Standard form was 2.2. This one's going to be 2.3. In fact, it goes up a bit. And 2.3 was factored form. F-A-C-T-O-R-E-D. And it gave us really the only set of points that we hadn't seen yet. We've been able to find the vertex a couple different ways. We could figure out whether the thing opened up or opened down. We were able to find the y-intercept really nicely in standard form. The only things that we haven't figured out yet are the x-intercepts. And those are actually probably the most important things that you're going to want to be able to find with quadratics. And that's why the next few sections only focus on x-intercepts. Okay, because those are the trickiest to find sometimes because they're not always nice. it could be at like weird spots. It could be at like strange decimals or even like nastier square roots, like the square root of 2 or 3 or square root of 11, stuff that just doesn't work out quite so nicely. And we know from first semester that, okay, if it's a square root of 3, cool, square root of 3, done. I'm gonna leave it just like that because that decimal goes on forever. All right, factored form, super quick. I did F, I did G. Let's go to H, doesn't matter what letter I use. I'll call it H of X. What's the first thing that you think is gonna show up after this equal sign? Every single time. Say it again.
A.
Always, okay? Because if I have some vertical stretch, or if I want to flip this thing upside down, that's where I'm going to put that number. Now, it might not be there. Remember, like that standard form one, it was just a 1. That's not going to do anything. Multiplying by 1 doesn't change anything. But if it's there, now I know, okay? Now, here's the thing that's different about factored form. When we talk about factors, to factor things is to write it as multiplication. So I'm going to put 2 sets of parentheses next to each other, where the first thing that goes in is X. Both of them just X and leave a little space, and then X and leave a little space. Okay. Now, because we're inside parentheses, things are always going to be backwards. So I'm going to put some minuses next to them. And the letters that I could put here don't really have a set across mathematics kind of rule for what's going to work. And so I don't really care what we call them here. I'm going to call them roots. I can call them x-intercepts. I could call them answers. I could call them a lot of different things. I'm going to call them roots. So I'm going to use the letter R for both. So I'm going to call it like R1, like a little 1 down here, and an R2 down at the bottom right there. So you can tell them apart. But like I looked it up, like I've been teaching this, I've been teaching some form of algebra for 10 years, and I've never settled on what to put right there. I looked it up like 100 times. Doesn't matter. All that matters is that these right here, R1 and R2, are the roots or the x-intercepts. Okay. Those numbers right there are the spots, not whatever this thing looks like. I don't care what it looks like. There it is, R1 and R2. Okay, and I'm going to leave us with that right there. Okay, because what I want to do from here in section 2.3 and kind of beyond that, I would probably get myself started and then I wouldn't be able to finish before the end of class. Plus, this gets you out a little bit early too. So, so now you've got some beginning. Okay, this is 2.3. This is where we're going to pick stuff up tomorrow. We're going to start with stuff that looks just like this, but I'm going to make it simple to begin with. I want to build us back to being able to solve for those x-intercepts because we did that right at the end of last semester and we didn't really have a great grasp on it. So I want to start there, but I want to show you how to get from a 2.2 standard form thing to a 2.3 factored form to be able to find those x-intercepts because standard form can't do it, and you'll see why when we get to tomorrow. Cool? All right. You guys are awesome. Thank you guys for hanging out with me for the last 30, 45 minutes, something like that. And you're good to go. Now, remember that tomorrow we're back on that normal timing schedule. I know that we started class today at 12:30. I think tomorrow gets us back to that 12:15 range. But I will always put the link to the Google Meet with the start time right on the announcement on campus. All right. Stick around if you have any questions, if you want to ask me anything. Otherwise, I will see you tomorrow on 12:15.
Bye, Rosie.
Before that, see you guys.
Thank you, Byron.
Peace.
See ya.
Bye-bye.
Bye, Danica.
Oh God.
Oh, you're good, Gavin. No worries, brother.
Hey, Rosie.
What's up, Aaron?
Hold on, sorry.